Okay, exponent properties is the next standard, and this really isn't too terribly hard if you just kind of follow directions. 4 to the third power, you know, I don't know what that means, and that means, 4 is what's called the base, and 3 is what's called the exponent. So what I do is I'm going to write 3 of my bases because the exponent's 3, and I just multiply those together. So 4 times 4 times 4 is 64. Okay, sometimes the base is a fraction, but that's not that hard. Okay, you just write 1/4 down twice and just multiply those. Now to multiply fractions, you just multiply across. 1 times 1 is 1. And 4 times 4 is 16. Therefore, 1/4 to the second power is 1 over 16. Okay, -5 to the third power. Again, my base is -5, so you can write 3 of those out, and you're just going to multiply those together. So that equals -125. And by the way, if your base is negative, if the exponent's even, or if the exponent's odd, if it's an odd number, then your product's going to be negative. Because that's positive, but then times by another negative takes it back to a negative. Okay, -2 to the fourth power. So -2 times -2 times -2 times -2. So 2 times 2, that's going to be positive 16. Now the reason why that one's positive is because this time I had a negative base, but my exponent was even. So then that's a positive, and that's a positive. So it's going to be a positive product. Okay, so if I have a negative base with an odd exponent, I can expect my product to be negative. But if it's an even, I can expect it to be positive. Okay, now there's a couple things. We're not doing it this way in class, but I have x to the third times x to the fourth. Well, I don't know what number x is, so to simplify it, we think, okay, x to the third, whatever number x is, that means there's going to be 3 of them times 4 more of them. Now, how many x's are there altogether? Because x to the third and x to the fourth, I count 7 of them. 1, 2, 3, 4, 5, 6, 7. So x to the 7th. Now, when you have the same base with different exponents, you can just add the exponents together. Okay? So you got to know that property, that rule. Now, this time I have x. Don't know what number x is, but I know it's to the power of 3. And then that is to the power of 4. So there's 2 powers here. So here's what I'm going to do. I'm going to write x times x times x, because x is a third, but then I'm going to do that 4 more, or 3 more times, so there's 4 of them. So that's 1, 2, 3. Okay, so again, x to the third, and then there's 4 of them, 4 of the x times x times x, x times x times x. Okay, so bottom line is when I count the x's this time, how many do I see? I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's x to the 12th. So you have to ask yourself, okay, what do you do with 3 and 4 to get 12? Well, I think you can just pretty much times them, and you can. It's called what's called a power to another power. You just times the powers. Okay? Okay, so remember those rules. Now you're simplifying with exponents. These first 2 are very simple. So I have the same base. I see the base twice, and I just need to add the powers. So 5 plus 10 is 15. So x to the 15th power. Okay, the next one, again, x to the third power to the 4th power. So it's a power to another power. So the power of 3 to the power of 4, we just times those together, and that's going to be 12. X to the 12th. Okay, now things get a little more dicey. They throw in numbers and they throw in variables all at you. So I see x to the 7th power times 5x to the 8th power. I would suggest you make 2 boxes here, And first, what I want you to write down is your bases. What that means is you basically ignore the little exponent numbers to begin with. Okay, so the 7 and 8. Okay, so for number bases, I have a 5. And then for letter bases, I have X. I have 2 of them, but I'm only going to write X down one single time. So I'm only going to write, if you have the same, like 2 of the same base, like I do X and X, just write it down one single time. Okay, now we got to put what the exponents are going to end up being. So look at our 5. 5 is just to the first power since it has no exponent. I'm going to put a 1 there. And that's the only 5 I have, so I just put a 1. Now I have 2 different X bases, X to the 7th, X to 8. So I write 7, 8, and I'm just going to add those together. So 7 plus 8 is 15. Okay, now what's the second box for? The second box is any number bases with exponents, you need to get rid of the exponents. So like 5 to the first we know is 5. So the answer is 5 times x to the power of 15. Okay, my next problem. I have a parentheses with 3x to the third power raised to the second power, and then another parentheses with 4x to the second with all of that stuff raised to the fourth power. So here's the best way to go about this. So ignore your little exponent numbers. Just write the bases down. So what do I have for big number bases? Well, I have 3. I also have 4. That's pretty much it. All the rest of the numbers are exponents. Okay, now for letter bases, all you have is X. You have X. I know there's 2 of them, but just write it down once. Okay, so let's find the exponents that go on these bases. So 3 has no power, so it's to the first power, but it's in a parenthesis. So when it's in a parenthesis, you need to take the exponent times the outside exponent. So what's 1 times 2? It's 2. So 3 is to the power of 2. Now let's go find the 4, and that's to the first in a parenthesis. So when it's a parenthesis, you got to take 1 times 4, and that's to the fourth. Okay, now for x's, I see 2 of them. Okay, so for our first x, I have a third power, but that's in parentheses, so I got to take 3 times 2, and that's 6. Put a comma, because there's another x. And then 2 times 4 is 8. Now I add 6 plus 8. You're always going to be adding those today. There's going to be some coming later where you subtract, but not on this assignment here. Okay, so I have some number bases. I'm going to circle them. 3 to the second and 4 to the fourth. Now, you can find 3 to the second is 3 times 3. That's 9. That should be common knowledge. And then 4 to the fourth, I can do one of 2 ways. I can just go 4 times 4 times 4, multiply 4 4s together. Or 4 to the fourth, you can hit 4 as your base and hit this little caret button because that's your power, okay? 4 to the fourth power is what that says, and that's 256. So 9 times 256 times x to the 14th power. Okay, so now these guys, what I'm going to end up doing is multiplying them together. So 9 times 256 gives me 2,304 times x to the power of 14. Okay, and that's simplified. That's all you're doing, simplifying it. And you're like, well, how do you simplify it? I'm giving you the directions to simplifying it. Okay, my bases here, I have a 6 and a 5. So 6 times 5. And then for letter bases, I have x again, but don't write it twice, just once will do. So 6 to the first, so I take 1 times 3, and that's 3. Then 5 to the first, that's in a parenthesis, so I take 1 times 2, and that's 2. Okay, now for x, I see 2 of them, so I have a second power. I got to take 2 times 3 to give me 6. Put a comma because there's another x, and then 2 times 2 is 4. So I need to add 6 and 4, and that'll give me 10. So x is to the power of 10. Okay, now 6 to the third. Remember, I can do 6 times 6 times 6, or I can go 6, hit the caret button with the 3. That's 216. So this now changes into 216. 5 to the second, it's 5 times 5, and that's 25. Times x to the 10th. Now, these two numbers here then need to be multiplied. If you end up with two big numbers like that, you're going to need to multiply those. So 216 times 25, and that's 5,400. So 5,400 times x to the 10th power. Okay, my next. Again, get the boxes made up. So number bases. I don't have any number bases. All the numbers I see are powers. They're those little numbers. And the only letter base I have is x. Okay. So I take 3 times 2 and get 6, comma, and there's another x. 4 times 3 is 12. So 6 plus 12 is 18. So my x is to the 18th power. Okay, next up, my big number bases are -3 and 4. So -3 times 4, and then I have a letter base of x. I see it twice, but I know that that's the only letter base. So -3, I take 1 times 2. Again, that's 2 because it's in parentheses. Now 4 is to the first. Here's 4. But it's not in a parentheses. So if it's not in parentheses, I don't multiply. I just put the 1 that's right there. Then x, there's two different ones. I can take 3 times 2, and that's 6, comma, and then I have 6 right here. So 6 plus 6 is 12. Okay. So -3 to the second. -3 times -3 is 9. Now, if you're going to use your caret button with a negative, you have to get the negative in a parentheses. Okay. 9. Okay. If you don't use a parentheses, you'll get the incorrect sign on your answer. So I've got 9. 4 to the first is 4. And then times x to the 12th. Now we can't leave these two big numbers unmultiplied, so I need to multiply them. That's 36 times x to the 12th. Okay, next one. My bases are -2. That's your only big number base you have. And then I have letter x twice, but just letter x. I've got another letter with y. Okay, so -2 is to the first. So again, I take 1 times 3. That's 3. The x is to the third here, but it's in parentheses. So I take 3 times 3, and that's 9, comma. And then there's another x here with a 6. So 9 plus 6 is 15. Okay, and then there's only one y right here. It's to the second, but it's in a parentheses. So 2 times 3 is 6. Okay, so I got to figure out what this guy actually equals. -2 times -2 times -2, or you can parenthesize -2 and raise it to the power of 3. -8 either way. Times x to the 15th, because the base is a variable I have no way of figuring out, times y to the 6th, and that's your only big number, so you don't have to do anything else. That's going to be your answer. Okay, next up, my bit number bases is 4. And then letter bases, all I have is w. So 4 is to the first, so I take 1 times 3, and that's 3. W, I have 2 of those, so 3 times 2 is 6. And there's another w, and I got to take 2 times 3. That's also 6. So 6 and 6 make 12. Okay, so 4 to the third. Again, you can take 4 times 4 times 4, or 4 exponent 3. That's 64. One thing, don't take 4 times 3. That's wrong. 64 times w to the 12th power. All right, and then we got these two. So my bases, I have a big base of -2. That's your only number base, and then n is my only letter. So -2 is to the first, but it's in a parentheses, so 1 times 3 is 3. Then for n, I have 2 of those, so 2 times 3 is 6, comma, and then another 6, and 6 and 6 make 12. Okay, so again, if you're going to use the caret key, you got to put your negative in parentheses, otherwise it gives you the wrong sign. So that's -8 times n to the 12th power. Okay, number bases, I have -4 and 12. And then for letter bases, I have A, and then there's a B. Okay, so let's get some exponents on these guys. So -4 is to the first, but it's in a parentheses, so 1 times 2 is 2. The 12 is to the first, that's in a parentheses, so 1 times 2 is 2. Now for the A's, there's 2 of them, so I take 2 times 2 and I get 4, comma, because I know there's another one coming, and 4 times 2 is 8. Then I add 4 and 8, and that gives me 12. Okay, B, 3 times 2 is 6, and there's another one, so I make a comma. 5 times 2 is 10. So 6 and 10, when I add those, that gets 16. Okay, so -4 to the third, again, or to the second, sorry, it's just -4 times -4, 16. 12 to the second means 12 times 12, not 12 plus 12, not 12 times 2, it means 12 plus 12. That's 144, and then I can't figure out the letters, I just put those where they go. Now I can't leave these two big guys, they have to be put together by multiplying. So 16 times 144, and that is 2,304. So the answer is 2,304 times a to the 12th power times b to the 16th power. All right, guys, this gets kind of more complicated as you go along. The first two don't make the boxes, just do what you need to do, and then you got 6 more.